Good morning. This is your Stat Sensei, Mr. Spensei, and this is going to be a warm-up on two sample proportions, and we're going to do the conditions for both a hypothesis test and for a confidence interval. And this is also in your notes spiral. The scenario is auto defects. An automobile manufacturer randomly assigned 850 cars to two distinct assembly methods. All right, we have something different here, or something we got to refer back to. Randomly assigned. All right, we can't say it's a random sample. We have to say it's randomly assigned, and we randomly assigned 850 cars to two distinct assembly methods. The reason it's important it says randomly assign it, first of all, our first condition, we can't say random sample. We have to say randomly assigned. And because it's randomly assigned, there is no second condition. Condition two went away, and we'll show that in just a moment. 350 cars were randomly assigned to the first method, resulting in 28 with defects. Okay, so our sample size for the first one is 350, and we have 28 defects. The 500 cars assigned to assembly 2, so N2 is 500 with 32, not X bar, just X2 equals 32 defects. Is there enough evidence at 10%? So this is our alpha to indicate the second assembly resulted in fewer defects. Now, this is a key word. If we were running the test all the way, we go our alternative would be N1 or proportion 1 has greater defects than proportion 2. But here's our information. 28 out of 350, 32 out of 500, and then 28 divided by 350 is 0.08. And we'll check that out real quickly. And please remember, this is because this is p hat 1 equals x1 over n1. This is simply p hat 2 equals x2 over n2. I think the work shows it really well there, but I wanted to point it out again. All right, conditions. The first condition, random assigned. Really important. You need to say random assignment or randomly assigned. Either one is fine. And we randomly assigned 350. All right, that means we have two independent samples, so we're good to go with the independence part. Then we always want to sit there and go, oh, 350 times 10, but no, we don't have that. That one is gone. We don't have it. Why? Because it's randomly assigned. If it's random assignment, we don't have that condition. Yay, we don't need to write that down at all. So we scratched, I wanted you to see it, but we scratched it out because it's incorrect. All right. The next thing we have to do is we need to make sure that our sample is big enough. But to be big enough, we have to use p hat c. It's like, oh, we don't have p hat c yet. So we need to calculate p hat c. So to calculate p hat c, we have to go to our formula, and our formula for p hat c equals x1 plus x2 in parentheses over n1 plus n2. So in this case, we'd have 28 plus 32 over 350 plus 500. So what's 28 plus 32? Some of you real quickly told me it was 60. And 350 plus 500 is 850. So we have 60 divided by the 850 is 0.0705. And that is P hat C. So going back down, 350, that was our sample size 1 times our p hat c of 0.075 equals 25. Let's try that out. Times 350. All right, so 24.7. And that's greater than or equal to 5. And then 350 parenthesis 1 minus 0.0705 is 325. And 325 is also greater than 10. So both of these are greater than 10, and we're good to go. I'd rather, it's not round, I'd rather this have been written as 24.7, and this one 325.3. Greater than or equal to 10, greater than or equal to 10. All right, moving on to this one. We have 500 times 0.0705, and that's 35.25. And 35.25 is greater than or equal to 10, so that's good to go. And then 500 parenthesis 1 minus 0.0705 is 464.75, and that's greater than or equal to 10. All right, so we can say both samples are large enough. All right, and we'll run the rest of this hypothesis test in our note spiral. The next thing says create a 90% confidence interval for the difference. Well, random assignment. Oh, 350 and 500. There were 2 independent samples. That's exactly what we had before, so none of that changed. This first part is exactly the same. The n is less than 10%. Oh, we had random assignment, so we don't need number 3. That's why we marked it out. All right? But we do have a difference. Up here we had p hat c. Super important. P hat c. Here, p hat c. But over here, we're using p1, p hat 1, and p hat 2. So we need to go back and look at what p hat 1 and p hat 2 were. Well, p hat 1 was 0.08. So 350 times 0.08 is 28. And then 350 parenthesis 1 minus 0.08 is 322. Both of those are greater than 10. The sample is big enough. Over here, we have p hat 2 as 0.064. So we're going to go 500 times 0.064 and get 32. And then we'll have 500 parenthesis 1 minus 0.064. And we get 468. So both of those are large enough. So we can say both samples are large enough. And if this was AP statistics, you say both samples are large enough to use the normal approximation. All right. I appreciate you watching. I hope that helped out a lot. Look forward to seeing you. And please do note, big difference. We have p hat c when we're working with a hypothesis test, and we have p hat 1 and p hat 2 for confidence interval, and p hat c is x1 plus x2 divided by n1 plus n2. Thanks for watching. Look forward to seeing you on the next one.